BLUF Gaming here with a detailed review of weight sales and ship weight. A new sloop can carry 3,300 kilograms, a new schooner carries 9,000, a brigantine 15,000, and a galleon 30,000. You can increase this allowance by spending points on weight after gaining ship levels, or by using weight sales. Weight sales are most similar to speed sales, but they add 425, 750, or 1,100 kilograms to your weight allowance depending on what size sail you use. They open and close a bit slower than a speed sail, and the angles at which they can effectively use wind are the same. They are, however, slower than speed sails. A ship with one weight sail is only 60% as fast as a ship with one speed sail if both ships are using the same percentage of their total weight allowance. The more weight you put on a ship, the slower your ship will travel. Weight to velocity is not a linear relationship, but rather a curve. The more weight you add to your ship, the more each kilogram slows you down, until your ship will stop completely at full weight. This means that if your ship is at full weight and can't move, replacing a speed sail with a weight sail will make your ship faster. Of course, if you have a low weight ship and you replace a speed sail with a weight sail, you will only be making your ship slower. Somewhere between low weight and full weight then, there must be a point at which both sails are the same speed. If your ship spends most of its time below that weight, you want speed sails. And conversely, if your ship spends most of its time above that weight, you want to start switching to weight sails. There's no easy answer for when you should upgrade a speed sail to a weight sail, but very generally speaking, you want to exchange a speed sail for a weight sail when your ship is regularly carrying more than 80 to 85% of its total weight capacity. More specifically, assuming these are level 1 ships using only speed sails, you want to replace a speed sail with a weight sail as follows. Schooners with one large and one small sail should use a small weight sail above 7,032 kilograms. They should use a large weight sail and a small speed sail above 8,260 kilograms. Brigantines with 3 large speed sails should substitute in a large weight sail above 12,435 kilograms and a second large weight sail above 13,056 kilograms. Galleons with 6 large speed sails should substitute above 24,212 kilograms. Also popular are galleons with 4 large speed sails and 2 large handling sails. These should drop a speed sail in favor of a weight sail above 24,651 kilograms. And before I forget, a sloop probably isn't the ship you want to use weight sails on, but don't switch from a medium speed sail to a medium weight sail until you're over 90% full, around 2,989 kilograms. Leveling your ship and spending points on weight, of course, changes the equation. And speaking of equations, in case you're curious how I got these numbers and how they might change as you level up your ship, I'll be sharing all these equations and supporting them with experimental data later in the video. That's your bottom line up front. If you'd like to see more detail, go grab your algebra hat and stick around. Thanks for sticking around. In case you haven't watched my speed sail video, you may have noticed the video during the intro was showing a brigantine travel through a course marked by claim flags. I use this method along with a fixed wind speed and fixed wind direction using console commands to come up with the data that I've collected. Several of you said you missed seeing that type of footage whenever I made my handling sail video, so I'm bringing it back this time. I've already showed 2 complete runs in the intro, so the rest of these I'll be cutting down some, but I'll be choosing the most important ones out of the hours of footage I did record. And just in case I'm talking about something else at the time, I'll be labeling each one of them as they come up. Okay, let's say that if a ship is going full speed, it's at 100%, and if it can't move at all, it's 0%. Another way to write 100% is 1. So let's start with 1, assuming that the ship can travel at full speed because it weighs 0. It doesn't weigh 0 though, and the more that it weighs, the slower it goes. So there's some sort of ratio of current weight, we'll say weight current, and then the max weight, weight max. So 1 minus that will slowly go towards 0 as weight current gets closer to weight max. If we just left our equation like this, it would be linear, but we know it's not linear. Instead, it's a curve. That means it's going to have some sort of exponent up here. So it does shrink faster as you go along. So we could try a few different exponents to see if any of them match, but I've already done that. And it looks like the exponent that matches is actually 1/2. That's also known as a square root. If you'd like to test out this equation, go ahead. An interesting point in the equation is whenever you're at 75% of your total weight. So say if you have a ship that can hold 10,000 kilograms, whenever you're at 7,500, what you end up with is 0.25 square root, which is 0.5, or half of your maximum theoretical speed. You can't actually reach that maximum theoretical speed, so double the speed, because that would require your ship to weigh nothing. However, it is a handy point that you can start off on. If you want to plug this into Excel, you can use it to predict what your speed would be at different weights. We'd also like to know how this equation works whenever we're using a weight sail. Well, a weight sail goes 0.6 or 60% of the speed of a speed sail, assuming they have the same ratio of current weight to maximum weight. One difference, however, that I haven't written in yet is that the weight sail is going to increase the total amount of weight that you can carry on your ship. So you're going to add some other weight. Let's use a medium weight sail as an example and add 750 there. So in order to determine when we have to change from a speed sail to a weight sail in order to gain speed, we need to know when this equation will be the same as this equation. So let's use a simple example and take a look at that. Let's start with just a sloop, since we're only going to have one medium mast on a sloop. So your basic sloop starts out with 3,300 kilograms of capacity. So let's write out the equation for how fast it would be if it was using a medium speed sail. And on the other side, let's set it equal to what we would have if we had a weight sail. A medium weight sail adds 750, so we end up with, oh, I can't add apparently. So we end up with 4,050 kilograms of capacity here. And what we need to do is solve for the current weight. What we have is the speed with a speed sail set equal to the speed of the same thing with a weight sail. And when these are even, we'll find a weight above which a weight sail makes sense and below which a speed sail makes sense. If you're not familiar with Wolfram Alpha, I highly recommend it. It's a free website, works kind of like Google, except it tries to compute an answer rather than search for an answer. And you could plug this that I've underlined here, you can plug that into Wolfram Alpha and it will solve it for you. Let's go over one more example, and then I'll put a lot of these equations in the description below or in a comment below so that you can copy and paste them and use them for whatever purpose you have. So this one, let's do a ship that has multiple masts. Let's take a look at the Brigantine. So the Brigantine at full speed is going to have the same equation as before, except this time instead of weight max, let's go ahead and write in the 15,000 kilograms that your standard Brigantine can carry at level 1. And then we want to find out when we should change one sail over to a weight sail. We're not looking at all three right now. So two of the sails, or 2/3 of its force over here, are going to stay the same. So let's write out 2/3 and then 1 minus weight current over, now this side over here, this side actually does have additional weight. We're adding a weight cell, right? So we're going to have to change the denominator here. And a large weight cell adds 1,100. So this is going to be over 16,100 100. And that's square root. And now the other 1/3 of this half has become a weight sail. So it is 1/3 of what we had before. And then 60% because the weight sail is slower. And then we have our normal equation of 1 minus weight current over 16,100. And I'm running out of screen over here to write on. So we put the square root up there up to 1/2. And this we can plug into Wolfram Alpha, and it will solve for us what the weight current is. And it tells us that weight current is 12,435.9 kilograms. If you were paying attention to the video that was playing behind my voice in the intro of this, I showed what a brigantine does over a given track. Using these equations, I determined the weight we needed right here. I showed 2 runs of a brigantine using that weight, one with 3 large speed sails, one with 2 large speed sails, and 1 large weight sail, and we got them running the track at exactly the same speed, 54 seconds. That's all the scribbling I have for now, but I do want to mention a couple of special cases, one of which has already been shown and one is being shown now. I showed 3 clips of a schooner, one with a large speed sail, another with a small speed sail that was excruciatingly slow, and another that had a large and a small speed sail. If you convert the time that they took to traverse this track into a velocity, you find that the 2 individual sails tested separately can have their velocities summed to equal the velocity of the pair together. This was used to come up with 2 different coefficients that are used to determine how much of the velocity of the ship is being provided by one sail or the other. In every other test case, we were only using the same size sails regardless of the sail type, so that type of differentiation wasn't necessary. The other special case is the one that we're seeing now, where you have a galleon using 2 handling sails and then the other 4 sails being speed. I wanted to include this one because it's a popular sail configuration, and because I wanted to include a coefficient for handling sails so you can know what to use for them, since they don't have the same 0.6 coefficient that the weight sails have. For handling sails, we use a 0.75 coefficient to adjust for their slower speed. And because we start with 2 different types of sails, our equation will have 2 parts on the left side of the equal sign and 3 parts on the right side. And of course, I've included this equation below. For all of the equations below, assuming they cover the sails that you're using, you can still use them after you level up and increase your weight capacity. All you have to do is just adjust the total weight capacity, i.e. the denominator in the equations, to whatever your current weight capacity is on the left side and whatever your projected weight would be with a weight sail on the right side. Of course, if you hate math, just remember what I said in the beginning of the video, where it's usually worth converting one of your speed sails into a weight sail whenever your ship hits somewhere between 80 and 85% of its total weight capacity. Although, if you hate math, why the heck are you still watching this video at this point? I don't understand that. Regardless, I hope this video was helpful for you whether you like math or not. If it was, please like and comment and let me know how I did. And subscribe if you want to see my future videos. I plan on having a few more about Atlas, as I cover the last few topics I still haven't made videos about, and then I'll move on to a different game. Click subscribe if you want to see these future videos, and of course, you can click dislike if you really don't like this video. If you do that though, I will fly to Mongolia and pay a soothsayer in lamb's blood to have your handwriting become as messy as mine. Hopefully everyone likes the video though and it doesn't come to that. And no matter what, thanks for watching Bottom Line Up Front, and I'll see you on the high seas.